All right, welcome back everyone. We're going to change gears slightly and move over to finishes. This is Division 9 from the master format, or corresponds to book chapter 9. So we're going to cover this in two different sessions. In this one, what we're going to talk about are the walls and ceilings. We're going to talk about plaster, Portland cement and gypsum, gypsum board, aka drywall, acoustic considerations, and paints. Next time we'll move on. We'll cover tile, terrazzo, carpet, wood flooring, everything on the floor covering. So let's get on with part one. When we look at finishes in general, we can look at the master format and see the numbering, and we can see that there's sections for plaster and gypsum board, tile, acoustic ceilings, wood flooring, terrazzo, acoustical treatment, painting and coating. So you can see how these relate within Division 9 for our subsections. For sustainability, as we've been starting off each one of these sections with sustainability, somewhat of a mixed bag. With gypsum, it is naturally occurring, however, it is non-renewable, so the more we use, we do have a limited supply. Acoustical treatments can have glass or mineral fiber, which can end up in landfill when we do need to get rid of it. Carpeting, not as bad because we can recycle our carpeting, because a lot of it goes into the padding underneath the carpeting. So if you've ever either placed carpeting or ripped up carpeting and saw the padding and it looks like it's this big jumble of colors and everything, because that's recycled carpeting. So that helps. We can also use the waste in a recycling manner for auto parts trays, garbage bags, and marine lumber. So let's take a look at this wall and ceiling finishes. There's really a couple primary things we're going to talk about. The first being plaster. And plaster is more of an older technique, and we can either have gypsum plaster. Remember, the gypsum is basically a lightweight concrete, or Portland cement, more of a traditional concrete type of plaster. And then nowadays, more than likely reason, this gypsum board or drywall. Later in this session, we'll talk about acoustic coverings and then paints. So let's start with this idea of lath and plaster. So what lath and plaster is like, well, I have some pictures coming up here, maybe it'd be better to see it, but here is some pictures of lath and plaster. We have either wood, this is your wood lath, these little wood strips, or you can have metal lath with this shape here. We'll talk more about those individually. But basically you have a structure that's going to hold on to this plaster, and the plaster is really your wall, right? So like I said, this was an older process. It really ended around after World War II. But the process is we first have to attach wood or metal lath, those either slats with a space in between them, or the metal, to our framing. Then we apply this base coat. It's also called a scratch coat of our plaster. And it's attached to this lath for support. So that's why we have that gap between the wood lath, because when I'm pushing that plaster in, it goes into between these gaps, creating a key, and that holds the whole wall in place, because this is kind of a heavy wall, right? If you think about a concrete-based material. After that coat, we scratch our base coat. So because we need the next coat to stick to that coat, we need to put some sort of texturing to it. So we're scratching it, basically creating little ridges. And then after we do that, we can stick on our next coat, which we call the float coat. And those two should stick together. And then we're floating it with a wood float. And that once again gives a surface that I can apply my last coat, which is like a skim coat, a lime plaster skim coat. And then I can finish that coat however I desire. Do I want it to be totally smooth? Do I want more texture to it? So that way, that's what you're doing in this last lime plaster skim coat. So that's the process, kind of labor intensive compared to drywall. And I think that's one of the main reasons it went by and by, right? When we talk about the individual materials, so plaster is a wet material. You can imagine it being like a semi-solid, right? And it's applied to this lath, becomes one solid system. Two types of plaster, either gypsum or Portland cement. The gypsum, of course, is much lighter. So the ingredients for our gypsum plaster, we have this powdered calcined. And calcined is a very dry white material, and then gypsum is the binder. So we're taking this powdered calciumed gypsum, we're adding water to it, and we get the right consistency. And we can see this is, you can almost envision that what this consistency is like, almost like a Frosty from Wendy's, right? Maybe like a toothpaste, and that's what we're spreading onto our lath. We also have to give it some more strength, so just like with concrete, we add some aggregates, and they're very small, gives it both dimensional stability and increases fire protection. We have lime that gives it more of the workability. We had the same thing when we talked about different types of concrete. And we can also add retarders and accelerators. Of course, retarders make it so that it sets up slower, so I have more time to work with it. Accelerators means it sets up faster, so I get it on quicker and it'll be ready for the next layer or whatever I'm doing quicker. As far as supporting that plaster, remember it's going onto this lath. And the reason we do that is if I had the plaster strictly sitting there, it needs some support. Otherwise, it would deflect and that would cause the system to crack. We also have to accommodate structural movement. So just like we've talked about all along, if things start moving, then we'll start having some cracking within our walls. Well, to prevent that, what we can have are these control joints or expansion joints, right? Same idea that we had in concrete, in masonry, where we also have it with our plaster walls. If we're going to do that, we need, if we have a joint in the interior that allows some movement, of course we need to follow that joint in the exterior. And here I can see a lath system where it does have an expansion joint built into it, right, to allow that to happen. We also need to account for joints that are going to have extra stress, like around windows and doors. So when we talk about the metal lath for the support system, we have a number of types: the stucco mesh, diamond mesh, flat rib, 3/8" rib lath, welded wire, woven wire, all sorts of different metal laths. Here you can see a 3/8" rib lath with the plaster being applied. And once again, you push it through that lath to get that strength, that structural strength, right? Portland cement, on the other hand, is a little more durable, and it's also a little more water resistant. So Portland cement plaster, same idea, but we can use it both on the inside and outside. So we're using this in the high moisture areas. So if we have wetting conditions like outside, we're going to use a Portland cement plaster as opposed to the gypsum plaster. When we're using it in an exterior application, you're probably familiar with the word stucco. That's exactly what stucco is. And you can either have a synthetic stucco or traditional stucco. When we talk about the cementitious material within this Portland cement plaster, we have Portland cement, plastic cement, and lime. Now, when we referred to Portland cement before with concrete, same idea here. Type 1, 2, and 3, remember those? Type 1 was our normal. Number 2 was our sulfate resistant. Number 3 was our fast setting. Type 1A, 2A, 3A, same idea with the concrete. Type 1 still being the most common. Of course, type 2, which was our sulfate resistant, would be what we would use over bricks or CMUs with that sulfate materials. And type 3 we said is a fast setting, so if it's cold, you need to speed up that process, use a type 3. In addition, we can also add in some natural cements, limestone, air entraining agents, make it more workable, remember that. Some plasticizers, also making it more workable, and lime, also making it more workable. So all sorts of ways that I can get it to push into the lath and smooth it out and trowel it and make it more workable. These admixtures, these are all admixtures, should not exceed 12% of the total volume of our mix. Here we see application that we have some woven wire ready for our stucco. Looks like it's probably an exterior. Here's your eave right here, and then the wall continues to go up, right? Some sort of detail where your stucco will go inside that little frame system. But like I said, more commonly now, interior. On the interior, we're gonna move on to drywall or gypsum board. Process here, a little less labor intensive. You're hanging these drywall panels, which are 4x8 or 4x12 typically. Then we're covering these joints with, and screws with, a joint compound, and we're taping. We had this tape in here. The purpose behind the tape is if I just had that joint compound in between and I had a joint, it would start to move as the building moves and cracks would appear in my drywall. So what this tape does is it's almost like an expansion joint, and it allows just a little bit of movement without actually cracking the drywall itself. So after you tape your seams and also your corners, your inside and outside corners, you do need to sand the whole process, and then you're going to have a second and third coat. And what you're really doing is you're tapering it out, right? So the idea is that if I only had this one coat, I'd have a bump there because I've added this material to my wall. Well, to get rid of this bump, I add more material and I taper it wider and wider and wider, making it so that you can't see the ridges in your drywall from each coat. So a little history. Started using drywall in 1915, or gypsum board in 1915. 3/8 inch sheets. 3/8 inch sheets were primarily used for remodeling. Over time, of course, the process got better and better. And then after World War II, we found out there's much less labor costs, and basically switched totally to drywall or gypsum board. So different types of gypsum wallboard. We have our regular core, type R. They have that gray liner paper on the back. You've probably seen this before in your local Home Depot or Lowe's, right? Manila paper suitable for decorating on the face, and longitudinal edges, typically produced with tapered edges. So this tapered edge, we'll see more on it in a little bit, but what it is if I have two walls that are butting together, if I taper the edges down, it gives me a little valley. And then when I have this edge, I can put in my first coat, tape it, put in my second coat, sand it, and when I build it up just flush. So I don't really need to taper it out as far because it's the tapered edges within the drywall. And we'll see a slide on that in just a little bit. We can have pre-decorated wallboard. If I want a finish already on the wallboard, I can have foil backed, has a vapor retarder built into the wallboard as well. I can have fire resistant wallboard. The way it is fire resistant is we have glass fibers inside, and I guess I should have started with this, but this wallboard, really what it is it's basically paper, a thick paper on the outsides. Then inside is your core, where you have your more concrete-like material, and that's where this glass fibers would be placed. We can also have water-resistant wallboard, so restrooms, bathrooms, kitchens, utility rooms, other humid areas. Colors have changed. They used to always be green. I think they're going more to a blue now, or purple. So it's usually differentiated from other wallboards, so you'll know which one it is. Or you can just read, order the right stuff, right? Not recommended for high moisture areas. If it's too much moisture, it will not protect you. You would need to have, well, you could still use that wallboard, but then you need an extra vapor barrier or water barrier on the outside of it. If you're in a shower room, sauna, steam room, something like that. So how do we get this water resistance? Once again, it's all about that core inside. We have now, instead of the glass for the fireproofing, we're adding this asphaltic additives. And we have this multi-layered covering of paper to try and keep that water out. As far as fastening our drywall to our studs, nails used to be the method of choice, but I think now more and more they use less often than screws. A lot of this had to do with the labor involved. So if we had nails, it used to be quick. To pull out a nail, tap it in, tap it in, tap it in. Where now, if you see this screw gun, the way these work is they're clutch driven. So you put your drywall screw on there, drive it home, and you'll hear a zing. And what it is, you hear the clutch, and it automatically presets to go the exact right depth, which is important. We'll talk about that in a bit. And then you can just doomp, 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 and it's much quicker to actually use the screws, and they hold better. So with these screws, we have different types. We have drywall wood screws, type W for wood, of course. We have type S for our metal, if I'm attaching my drywall to metal studs as opposed to wood studs, and type G if I'm attaching this drywall to drywall, right? So multiple layers of drywall or something like that. So drywall edge and corner trim. When we do have a corner like this, we need to protect this corner and finish the corner. So there's these metal pieces that will go around your trim, and they protect the corner both from chipping and also give it that nice rounded edge. So we can have it as being a sharp corner or more of a bullnose, a rounded corner. We can have a U bead, L bead, LK bead, or LC bead. You can see all the different varieties here. Really the corner bead is when you have a corner, a wall, and you're doing both sides of the wall, versus the U bead is almost like just encapsulating the end of a drywall. So you're just ending at that place, right? And same thing with the L, the LK, and the LC. What you're really talking about is what's going on the underside and how your framing goes and how you want it to attach. You can see different pictures over there. After we have our wallboard hung, we said we do have to finish our wallboard, our drywall. So we have a variety of finishing tools. We call these knives, where I can see I have different widths, and that's because, like we said, we start off with a smaller patch and we're tapering it out. As we taper our joint out, we need to increase the width of these knives, right? Ending up with looks like maybe a 12-inch knife at the very end. I can also have specialty finishing pieces for inside corners. I don't have a picture of that, but you get the idea. There are definitely a lot of techniques to taping and finishing. It is an art form. People who can do it quickly. I think the biggest issue is maybe you put on too much in the beginning, then you have to oversand, and then you put on too much second coat, and whatever. You can definitely tell when someone knows what they're doing with drywall. As far as defects, you can have nail popping. Here's a picture of a nail pop. What it means is the nail was not secure in there, and between movement it worked itself loose and popped through my coating of this of the finishing compound and the paint and everything else I have there, right? You can see it's due to loose boards, wood shrinkage, very long nails, improper nailing. Also, I can have an issue of punctured face paper. So drywall really gets its strength from those two pieces of paper on the sides. Once the paper is ripped, I lose all the strength of my drywall. And if you've ever cut drywall, or the way you actually cut it to size, the way you do it is you don't use a big saw. You just have a little utility knife, cut the paper, and just bend it, and it'll break right along that seam. But the point is that if you overscrew your drywall screws, then that piece is not usable. Just a couple pictures of the process going on. We can see that a couple things. You're going to not have your seams line up here, right, so that you wouldn't have a crack, and just give it more support. A couple commercial applications that we see. I can see the corner board here, and you can see that sometimes you may have to use a lift to finish this drywall, so it's very tall applications. So let's talk more about this nail popping. Here's another picture of a nail pop. Why does this happen? I can see that this drywall has worked itself loose from this support, right? That caused the nail to come out. Well, if I miss it totally, it would pop out. If I only catch a part of it and it's sideways, or if I didn't drive it all the way home, these are all reasons. Like loose boards can move and fluctuate. But of course, I believe the number one way you can prevent nail popping is use screws. So that's more common nowadays anyways. You have to consider what your framing looks like. This is like stick framing or like-gauge metal framing. We talked about both those systems. How are you going to support your wallboard, right? So you need to have your framing in a way where when I apply this, like if I put these two pieces together, then this would have been dangling in space. So I need some way to think ahead on how I'm going to attach my wallboard. Tapered edge, I spoke about this a little bit. So with this drywall, if I have a 4-foot panel on both ends, I can see it tapers down. And the reason I do that is if I have two ends butted together, then I can, when I'm jointing and when I'm putting down my tape and I'm putting my layers of compound, I end up building it to a flush surface. Ceiling, working on the ceiling is never fun. I see these two guys working with looks like a metal system. We'll talk about metal system in just a little bit. This is more maybe residential, but we have wood. But you can use these drywall hoists or various other ways to put the drywall in place. These are a lifesaver. This is a pain in the butt. I guess that's the short end of that story. But we talk about the support systems with a metal grid system to hold our drywall in place on the ceiling. I can see a couple systems here. Basically, they all work on the same principle of having a cross system that I can screw into. I can see here's an adjustable one if I have something more architectural that has some turns to it. But I do need support on the edge of the drywall. Drywall can't cantilever, it can't hold itself up. So I would need some kind of support system for my ceiling wherever the edge of the drywall is going to be. Moving over to acoustic panels. What are acoustic panels? These are panels you'll see on walls or possibly ceilings, and they are there to eliminate echoing and reverberation of sound waves and ambient noise, make the room quieter, soundproof in a way, right? They're made from sound absorbent wool, mineral fiber, insulation fabric. Here we see a wood one, looks like a fabric one on a wall. Here we see a one hanging from the ceiling. So when they look like they're suspended from the ceiling or just hanging in space, we call these an acoustical baffle. So these would be baffles up here, suspended from the edge or float in a cloud-like fashion. We could have acoustical ceilings. We'll talk more about these in a little bit, but this is an acoustical ceiling. All these panels are in this track system, right? We could also have wall panels just hung against the wall like this. And here we see a detail of an acoustic wall panel on gypsum board, where I have my board and I'm attaching my panel to the outside here. When we talk about these acoustic ceilings, these are very common in commercial applications. I'm sure you've seen them all over the place, where basically I have this rail system, and inside this rail I have these series of panels, most either being 12 by 12 or 24 by 24. Some can be rectangular. So how do I attach these? They can be adhered, meaning I can actually just glue it to a solid ceiling with an adhesive, or nail it and staple it to some kind of furring strips. However, most use these metal tracks, right? And here we see more detail in the metal tracks, usually some wires that hang up to your actual support. We have these main runners, cross tees, panels would sit in these little ridges in there, right? And here I see more of that support system with these hangers. We have direct hung versus indirect hung. Direct hung means that my panel is sitting directly on the support that's hanging from our structural members above, versus indirect means that I have some kind of channel, and that channel, which is hung from the top, is what's supporting our rail system. We can see the project manual for some requirements for something like this. We have size requirements, 24 by 48, thickness requirements, the material. This one's saying it has to be made out of a mineral fiber. Light reflectance, how much light's going to come back in. NRC 0.7, that NRC is noise reduction coefficient, how much sound is being absorbed. And colors and so on and so forth. So you can see quite a bit on the acoustical requirements. And here's a building, I think this is the computer science building, with my track system installed, but I don't have my panels. It looks like I have a couple panels in for my sprinkler systems and things. You can see that there's panels that are made directly for HVAC, where I have a vent right there. I can see that I have a little knockout here for a sprinkler system. And here I can see more detail of the sprinkler system coming through, poking through. And here's a light that's built into this panel. And here's the installation process. Basically they pop up, can move around. One huge advantage is that once the ceiling is complete, I can still have access to everything that's going on underneath. Any plumbing, electrical, anything I need to do, just pop the panel out, go up there, fix what you need to do, put the panel back in. So the last topic we're going to talk about today are paints and coatings. So paints include the air dry materials that are applied as a liquid in the field. However, sometimes things can be applied at the factory, maybe applied in a different manner. So we're talking about primers, emulsions, enamels, opaque stains, sealers, fillers, any applied materials used as either a primer, an intermediate, or finish coat in this painting process, right? So that's what we mean by paint. When we say coatings, it could be air drying or baked on. So you could think of something like, it looks like something that's going on here. It's probably a powder coating, where you're putting a powder on and baking it on. And it can include anodizing on aluminum or baked enamel or things like that. So the first coat, the primary coat, is called the primer. And this is like your base coat, right? It helps hide imperfections. It helps give your base or your final coat something to adhere to, things like that. It is a mixture of minute solid particles known as pigment. That gives you your color, of course, suspended in a liquid medium called the vehicle, and that's true for all paints. So different types of primers. We could have a latex. I need a little bit here. There are emulsion paints for use on gypsum board and masonry faces. Dry quickly. You can recoat within hours. Wash up with water, which is a huge advantage, and excellent alkali resistance. You could also have an alkyd. Made from an alkyd resin, suitable for all surfaces except paper resurfaced gypsum board. Then you want to go probably to the latex. Do need a little bit longer, like overnight before recoating. Oil-based, similar to alkyd, except thinner and dry slower, and alkali resistant, made of this copolymer, and that's suitable for any alkaline surfaces like damp or partially cured masonry. When we talk about interior wood, we would want to coat that with either an enamel. You can see alkyd, oil, latex based, some of a low gloss type of hiding ability to them. In general, the higher the gloss, the more you see imperfections and things. Something to keep in mind. This would create a smooth finish. I could also use a clear wood sealer. So the clear wood sealer lets the wood shine through. I see the wood. It gives it the same appearance of the wood, but seals up all the pores to keep anything from going in and staining the wood. I could also use wood fillers. So wood fillers, if I have any imperfections in the wood or notches in the wood or scraps in the wood, I can fill it with a wood filler. Usually do the wood filler and then I can add my sealer or my undercoat. Interior top coat. So we talked about priming. What about the top coat? We can have different finishes, either a gloss finish, a semi-gloss, or a flat. And you can see the different types of paints which would give me each one of those types of finishes. But I think more importantly, just understand the difference. The glossy finish looks more wet, shows more imperfections. Semi-gloss, you can break that down further and either have it as an eggshell or a satin. Satin being slightly more glossy than eggshell, if I remember right, and then flat. So with paint, we still need to prime our surfaces, and you can see based on what material I'm using will determine my primer. If it's a gypsum board, we said the latex worked great. If it's brick, I could use a latex. If it's a CMU, definitely need to put a block filler in first. Concrete, metals, I need something that's rust inhibitive, and galvanized metals, don't really need anything special, but you need to prime them anyways. You need to prime wood, and acoustical surfaces would need to be primed too, I suppose, if it's an acoustical that is not a fabric, before painting. And then exterior top coat paints, we could have oil, latex, or aluminum. Not so much the water-based paint because it is exposed to weathering, and to have it last we need the either oil-based, latex-based, or aluminum, which will block out the water. And we can see more in the project manual about what kind of paints would be needed, and even some brands: Benjamin Moore, Pittsburgh Paint, Sherwin-Williams, primers and thicknesses and everything like that. More of the same, filling in concrete masonry blocks and prime coats, pigmented finishes, transparent clear finishes. So all this information you get from the project manual on distributor or manufacturer, but also other requirements on the application process. So that's what I have. Hopefully you found that informative, and I look forward to talking again for part 2 soon. See ya. Bye.